Today we're going to talk about lesson 7-5, the language of functions. The big idea today is a function is a relationship in between two variables. Normally we use x and y, in which the value of the first variable is associated with or determines a unique value of the second variable. You're going to hear me a lot say things like input and output. And what I want you to remember is input is the numbers that you put in. Therefore, they are your x values. Your output are the numbers that you get out after you put in your x values, which are our y values. Whenever you have an input-output value, you always get a coordinate point, x comma y. In this course, you have seen many situations that involve two variables. In an investment situation, the length of time that money had been invested determines the value of the investment. So T was our X, the amount that we received was our Y. In temperatures, the Fahrenheit temperature determines the Celsius. Fahrenheit was your input, Celsius was your output. In a sequence of dot patterns, the term number determines the number of dots. Okay? Term number, input, number of dots, output. When the value of the first variable determines the value of the second variable, we have a relationship which is called a function. Squaring a function. Consider the squares of the integer from 1 to 10. There are two variables. The first is the integer. The second is its square. We can describe the relationship between these integers and their squares in many ways. Okay? The equation they are using is y equals x squared, which is right down here. Okay? Where x is an integer from 1 to 10. So we're only going to put in numbers 1 all the way down to 10, as you can see over here at my left. Okay, so they put in 1 through 10. Those are the numbers that you're going to put into this equation. This is my input. This is my output. Together, these form a coordinate point, just as well as you would see on your calculator. Okay, so when you put 1 in here, 1 squared gives you 1. If you put 2 in here, 2 squared gives you 4. You put 3 in here, 3 squared gives you 9. And as you can see here, they plotted those points right on here. Okay? Inputs, outputs. This is called the squaring function. Why is it the squaring function? Because 2 we call squared. Anything to the 2 power is squared. Okay? In general, you can think of functions either as special kinds of correspondences or as special sets of ordered pairs. A function is a correspondence in which each value of the first variable, as I said, is the input, corresponds to exactly one value of the second variable. It cannot go to 2. We'll talk about that later. 1 input goes to 1 output, okay, which is also called the value of the function. We think of the first variable as determining the value of the second variable. I always like to say you can contribute it as a gumball machine. You put in a quarter to a gumball machine, you get out a gumball, okay? In the squaring function, we put 1 in, we also got out 1. You put in x equals 3, you got out of the squaring function 9. Okay? The graph on page 425 shows that the squaring function as a set of ordered pairs. We looked at that. A function is a set of ordered pairs in which the first coordinate appears with exactly 1 second coordinate. That is, once you know the value of the first variable, often called x, then there is only 1 value for the second variable, often called y. For this reason, The first variable is called the independent variable, and the second variable is the dependent variable. So, as well as we call them input output, this is your independent variable, and this is my dependent variable. Okay? How does this make sense? Well, if I put 25 cents in a gumball machine, I get out a gumball. Okay? If I put 10 cents into a gumball machine, what happens? There is no gumball. The function cannot go. Okay? So, in the gumball machine is dependent, getting a gumball out is dependent on what you put into it. Independent variables is your x values. Dependent variables are your y values. The domain and range of a function. The domain of a function is the x values that you can put into the function. I'm going to write that down here, or actually circle this right here. The domain is the set of x coordinates of the points that you can put into the function. Any value that you can put in is part of your domain. So if you refer back to our squaring function, in this case, if you look at our squaring function, they only wanted us to put in values from 1 to 10. So we can only plot those from 1 to 10. In this case, our domain was x values such that x is greater than or equal to 1, and x has to be less than or equal to 10. Okay? That was our domain for this one. If you look here at this function, our domain, it's still the squaring function, except they included negative numbers. Okay? Could you put in negative 9.5? Yeah, we'd get an answer right here. Could I put in a negative 5? Yeah, I'd get an answer right here. Could I put in a positive 5? Yeah, I'd get an answer right here. So on and so forth. So my domain for this function is the set, that's what this means, the set, x values such that, and x goes from, these are my x values along here, so that's what I look at, my x-axis, negative 10 all the way to a positive 10. So a negative 10 to a positive 10. Put in your inequalities, and that inequality says x values that are from a negative 10 to a positive 10. That's the domain. You look at your x values. What x values can you plug into this function? The range. The ranges are dependent variables. Okay? Looking at this function, we should know that numbers that we put in were always positive. We never got out any negative numbers. Okay? We only always got out positive numbers. Okay? And so on your range, you're going to look at the y-axis. It goes from 0 to, well, could go on forever. But in this case, it only goes to 100 is the function that I'm looking at. So my range in this case is the set. Now, my range are y values. So I'm going to say y such that, and what does y go from? Y goes from 0 to 100. So what this says is y is greater than or equal to 0. Can it be 0? Yeah. Y is less than or equal to 100. Can it be less than 100? Yeah. Could it be right at 100? Yeah. So my range for this is from 0 to 100. Example 1 says consider the reciprocal function y equals 1 over x, which pairs real numbers with the reciprocals. Give the domain. Okay? I'm going to put this on my calculator because I want to look at a few things. I'm going to have to pause here and then get my calculator. Okay, sorry about that. I wanted to get my calculator up so you didn't have to watch that. But so what I did was I took this function, 1 over x, okay, and put it into my calculator. Now, I'm going to hit second function table because I'd rather look at it with my table. And as you can see here, I'm just going up by integers, 0, 1, 2, 3, 4, etc., 5, 6. But as you should notice, is I have an error at 0. What does that mean? Well, if you notice here, if I put in any negative value, I get out some negative value. If I put in any positive value, I get out a positive value. So basically what we're saying is for my domain, I can put in any real number. I can put in any real number except I can't put in 0. Now, why can't we put in 0? Well, think about this. If I put in 0, what's 1 divided by 0? It's undefined. You can't do it. Any number divided by 0 is undefined. So you can put in any value for this function, you just can't put in 0 because at 0, this function is undefined. Okay? So there's my A. B says, find the value of the function when x equals 4. Which means I want to find y when x equals 4. So I put in 1 divided by, what's my x? My x is, in this case, 4. So my value of y is 1/4, or what we know is 0.25. Okay? Looking at example 2. What are my domain and range of the function described by the equation? Well, looking at this equation, I should know this is a linear equation, which means it's a line. A line that technically goes on for ever. So here's a -3. That's my y-intercept. We should all remember how to do this. Y-intercept equals a -3. My slope is 4. So I got to go up 4 units over 1 unit. Not a very good line, but you get the idea. But I got a line that goes on forever. So in this case, my domain is the set. Could I put in 0.5? Sure, I could put in 0.5 and get an answer. Could I put in 2,000? Sure, I could put in 2,000 and get an answer. You could also look at this on your calculator and notice as far as you go up and as far as you go down, no matter what number you put in, you could get out another number. So my domain is x such that x is all reals. And all that means is I could put in any single number, decimal, whatever, and get out a value. My range. Could my range be positive numbers? Yeah, it looks like it goes on forever. Could my range be negative numbers? Yes. Looks like it goes on forever. So my y also is y is all reals as well, because this linear equation goes on forever. I could find a value that gave me a very, very large positive number. I could find a variable that gave me a very, very large negative number. Okay? Let's look at example 3. In lesson 7-3, the equation y equals 21,000 times the quantity 0.85t describes a function that models a car's value y when it is x years old. If it was purchased for $21,000 and depreciates 15% a year, what is the range of this function? So what you could do on your calculator is you could go ahead and graph it. Okay, Mr. Johnson's going to show you what it looks like. If you remember, it is a exponential decay problem because this number is in between 0 and 1. So it starts at 21,000. And then gradually it starts going down, 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 and almost reaches the x-axis. We're going to assume the car's worth something, whether if it's $1 or a penny, 18,000 years down the road, okay? So, looking at this, they want to know what is the range. If you remember, the range is my y value, so I'm looking at these values right in here. What is the range of my car? Well, my range can go as high as 21,000 and as low as, well, we could say as low as 0. I suppose at some point in time you could say the car's worth close to 0, so we're not going to include 0, so we're not going to put an equal sign on it. Okay, so we're going to say the car is worth from 0 to $21,000. Okay, so how do I write this? My range, this is set builder notation, is a set y, because we're talking about range, my y values, such that y goes from 0, it has to be greater than 0. We're going to assume that our car is always worth something. And less than or equal to 21,000. At one point in time, it's equal to 21,000, but as soon as we drive the car off the lot, it's worth less than 21,000. So it equals 21,000 on the lot. As soon as we get it off the lot, it's not worth that. So that is my range of this function. Relations that are not functions. Okay? The word relation describes any set of ordered pairs. It is possible to have relations between variables that are not functions. This happens when the first variable x in a relation corresponds to more than one value of the second variable y. For an example, the relation described by the equation x equals y squared does not describe a function. Why? When x is 4, then y is equal to 2 and a negative 2. That means my x went to 2 different numbers. If your x goes to 2 different numbers, we just call it a relation. Okay? We just call it a relation. A relation in this case is not a function. Okay? Every ordered pair you see is a relation. It's just that not all of them are functions. Functions whose domains and ranges are not sets of numbers. Okay? There are certain times when your range is not a number or your domain is not a number. It says it is possible to have functions whose domains and ranges are not sets of real numbers, or even that have little to do with mathematics. For an example, every person on earth has a unique blood type. So there is a function whose domain is the set of all living people on earth. There's my domain, the set of all living people on earth, whose range are blood types. O positive, O negative, AB positive, AB negative, so on and so forth. So you could say Mr. Johnson is an input, and I don't even know my blood type, but I'm just going to say I'm AB positive. Okay? So this is an ordered pair. Mr. Johnson is the X value, AB positive is the Y value. You could use Mrs. Pyle. Mrs. Pyle is a coordinate point. Okay? Miss Pyle is the X value, O positive is the Y value. So these are circumstances where you have domains and ranges that are not sets of numbers. That's all I have for you today. Thank you very much. We'll see you tomorrow.